So this lesson is on infinite limits. So when you look at a function that has an asymptote, which this one does because if you set that equal to 0, the values can't be a 2 because it would make the denominator 0. So you know you're going to have an asymptote. And as we approach 2, because it's headed in 2 different directions, then the limit does not exist. And you can see this from the table in your calculator too. If you were to type him in, you would see that as you approach 2 from the right, you're headed to negative infinity. And as you approach 2 from the left, I think I have that backwards, you're headed to positive infinity. Okay, but the limit from the left is headed to negative infinity, and the limit to the right is headed to positive infinity, and you can see that from the graph. But the limit overall does not exist. So you need to know these basic functions. This would be like 1 over x squared. This would be 1 over x, or 1 over x cubed. This could be 1 over x to the 4th. So even powers, we call them kissing functions because they head in the same direction. Odd powers on your x are going to head in different directions. If it's a negative, then they're going to be flipped and headed down. If it's a negative, they're going to be in quadrants 2 and 4 instead of 1 and 3. Determine the limit of each function as x approaches 1 from the left and the right. Okay, so here's my function. As we approach 1, because it's an even function and it's a positive, I know that they're both headed up. So I know that this function's limit is positive infinity. This one, because it's odd on the bottom, they're headed in 2 different directions. So from the left, I'm headed to positive infinity. But from the right, I'm headed to negative infinity. So the limit overall does not exist, but from each side it does. So just a refresher course on vertical asymptotes. Vertical asymptotes, you always set the bottom equal to 0 and solve it, but also remember that sometimes it's a whole and not an asymptote, and you need to make sure that you understand the difference between the two. A is going to have a vertical asymptote at -1. That's easy. The next one, if you were to factor the bottom, and nothing cancels with the top because the top does not factor, you're going to have a vertical asymptote at x equals plus or minus 1. Remember to put the x equals because that's what makes it a vertical line. Cotangent. We can remember cotangent. Remember the O has asymptotes at 0, pi, and 2 pi. And cotangent wiggles the opposite of tangent, so it wiggles down. And it keeps going. So he has tons of asymptotes. In fact, infinite number of asymptotes. And they all happen at some sort of multiple of pi. 0 pi, this would be negative pi, negative 2 pi. So I can say that he has asymptotes where x equals a pi, where a is any integer. An integer is just a whole number. It takes all the fractions and decimals out. For D, I can factor the bottom. And so I have issues at 0, 3, and -2, and they could all be potential asymptotes, but if you'll factor the top, that's, well, think about it this way, x plus 2 and x minus 2. So the x plus 2's cancel, which means this guy's not an asymptote, he's a whole. So really, these two are my only asymptotes, and the -2 is a whole. For E, I can factor the bottom. This is 4 terms, so this is grouping. So group the first two in GCF and x cubed. Middle sign always comes down, and then I can take a 4x, and that's going to leave me with x minus 3. Make sure you know where the minus comes from. And then pull the x minus 3 out front, and that's x cubed minus 4x, but then this can still factor. I can GCF an x out of that, and then I can do squares. So we actually have 3 types of factoring in one. Oops, that's a 2. Okay, so I potentially have issues at 0, 3, and plus or minus 2. So they could all be asymptotes, but I need to check the top. And I can factor that. So that cancels with these two. So these two are wholes. So those are the only 2 actual asymptotes. Secant. Think of secant as 1 over cosine, because we don't really know what the graph of secant looks like, but we do know what the graph of cosine looks like. It's very well behaved, but it does equal 0 sometimes, and you can't have a 0 on the denominator. So think about where your x values on the unit circle are 0, and that happens at pi over 2 and 3 pi over 2. So I can't be those numbers, which means I would have an asymptote there because that would cause a 0 in the denominator. So it happens at pi over 2 and 3 pi over 2, and then all multiples of that. So the pi and the 2 are constant, but then I'm going to put an a up here, and then I'm going to say that a can be any odd integer, because that's a 1, that's a 3, the next one would be a 5. Okay, then we've got properties of infinite limits. A lot of this is really common sense. It says that if I have limit of f of x being infinity, and the limit of g of x being some number, then if I'm taking the limit of f plus or minus g of x, I'm going to get infinity. Because think about it, if this guy's going to infinity, and this is plus or minus some measly little number, even if it's 100 or 1,000,000, it's not going to affect infinity because infinity is that big. So plus or minus some number is always going to give me infinity. When you multiply it, if f of x is infinity, and g of x is some number, if I multiply them together, I'm going to get positive infinity as long as that number is positive. If this is infinity and this is a negative number, it does change your answer to negative infinity. Infinity times a negative number is going to be negative infinity. Okay, and then this one is really interesting. If I have a plain old number over infinity, so these numbers are getting bigger and bigger and bigger and bigger, what happens to the fraction as a whole? Well, if I have 2 over 5, and then I go to 2 over 50, and then I go 2 over 500, what's happening to my fraction as a whole? Well, it's going to get smaller and smaller and smaller, and that's why the limit is headed to 0. Okay, so now we're just going to put these rules into practice. So for number 1, remember, your first idea, your first plan of attack is always just to plug the number in and see what happens. But if you plug a -2 in here, you're going to get a 0 on the bottom. So what I'm going to do is I'm going to factor the bottom, and that allows that problem to cancel. So now I'm going to reset my limit. Now plug a -2 in here, and you get a -1/7. I had a hole at -2, but I can factor it and cancel it out. And then if I reset my limit, I can just plug a -2 in, and I get a -1/7. On number 2, the bottom doesn't factor, but look at your 3. If you plug a 3 in, does anything bad happen? It doesn't. I get a 6 on top, I get an 18 on the bottom. That's a 1/3. So don't be so quick to think that all these limits are difficult, because some of them really aren't. That's your first step, is always just to plug it in and see what happens. Now, on number 3, when you plug this in, bad things are going to happen because you're plugging a 0 into the denominator. Well, the limit as x goes to 0 of 1 is just 1, because it doesn't have any x's. It's going to be 1 all the time. But let's talk about this guy. If I'm approaching 0, then my numbers are getting, like if I go 5, 4, 3, 2, 1, but then think of all the numbers between 1 and 0. Those numbers are fractions, like, let's say we have, like if this is 1 and this is 0. If I have a half, we'll plug a half in there, that'd be a 4th. And then Bojangles that with the top, that gets me a 4. So when I plug in a half, I get a 4. Okay, let's go closer. Let's go a 4th. Well, if I plug a 4th in there, that's a 1/16. Bojangles that's going to give me a 16. So what's happening to my fraction now? It's getting bigger. And then if I go 1/10th, plug a 1/10 in there, that's going to give me a 1/100th. Flip it, that's going to give me 100. And then I can try a 15th and a 20th and a 100th. All these numbers, when I square them and then flip them, it's going to make that whole number huge. So the limit as x approaches 0 of this piece is headed to infinity. And then infinity plus 1, I said this in class, it's like an ant and an elephant. An ant's not going to make much of a difference. So infinity plus 1 is just infinity. Okay, number 4. Headed to 0 from the left. So if I plug 0 into x squared, going to 0. You can do that numerically, or you can think about a graph. Okay, if I think about this, now I'm headed to 0 from the left. So we'll go from -1 and we'll get closer. So if I'm a -1/2, plug that in here, and then flip it, that's going to give me a -2. Okay, then take a -1/4 and plug that in there, and then flip it, you're going to get a -4. Okay, so these numbers are getting bigger, but they're negative. So this limit is headed to a -infinity. And then 0 and a -infinity is -infinity. So feel free to stop and take your time and pick some more numbers to plug in there to make sure that you have a good grasp of that. Number 5, if I do cotangent. So cotangent is the nice one. But it wiggles down. Okay, I'm headed to 0 from the right. To 0 from the right. So where am I going? I'm headed up to infinity. So 3 times infinity is infinity. Okay, 4x over secant x is the same thing as 4x cosine x. I'm headed to pi over 2 from the left. Okay, so you can think about this on the unit circle. Here's pi over 2. Cosine, well, if I plug in a pi over 2 here, that's just going to give me 2 pi. So that's that. All right, now let's see where cosine is headed. If I'm headed to pi over 2 from the left, I'm headed to 0, right? In that cosine's value here. So he's 0, and 2 pi times 0 is 0. Okay. So now let's look at number 7. I don't want to write sine of x as a cosecant on top. I really just want to leave it alone. So I'm going to have 4 over, all right, now think of sine, headed to 0 from the right. Yeah, Yeah, that's right. Headed to 0 from the right. Sine of x is, let's see, this is 1, 0. So sine of x is going to be 0. Well, I can't just plug a 0 in here, so that doesn't help me. I have to think about it. What if I thought about this graph of sine of x? Let's do this. And I head from the right. I'm headed to 0, but now I can think more about, well, what are my x values doing? Well, they're getting smaller and smaller and smaller. So if I have 4 over tiny positive numbers, and they're getting smaller, and I'm dividing them into 4, aren't they going to go more often the smaller they get? So 4 over, I don't know, a half versus 4 over an eighth versus 4 over 100th. Like that's going to 8, that's going to 32, and this is going 4 over 100. That's going to 400. These numbers are going to get huge. So as a whole, that goes to infinity. Because I have really, really, really small numbers on the bottom, and I'm dividing them into 4. So they're going to go more often, more times. So that's going to infinity. Okay, now same problem, but now we're headed to 0 from the left. Okay, so if I'm headed to 0 from the left, my numbers are getting smaller, but they're negative. So this is 4 over tiny negative numbers, which is going to make this whole fraction get really big really fast, but it's going to be negative. That's the difference. Okay. 7 secant x. I don't know much about the graph of secant, so I'm going to think about it like this. Okay, so 7 over. All right, now we're headed to pi over 2 from the left, and we're cosine. And cosine is headed to 0, so don't just plug in a pi over 2. Think about it. As you're approaching pi over 2, these numbers are tiny and positive. So if I divide 7 by tiny positive numbers, this is going to infinity. Think about it like this. Pi over 2 would be right here. So if I head to that from the left, my x values are getting closer and closer to 2 pi over 2. So they're getting smaller and smaller. And then when you put that under 7, that gives you a positive infinity. Okay. These are tricky. Follow the rules. Use everything in your arsenal. Use plugging it in. Use factoring. Use conjugates. Use graph. Use the unit circle. Use everything you can to attack these. And the more you do, the better you'll get. The more comfortable you'll get with them.